exciting, frightening, exhilarating, dormant and beautiful. Though it's when volcanoes spring to life and erupt that they give Earth scientists the best opportunities to discover the ways in which the Earth works. But how? Well, the first part of the analysis is to describe with precision what state a volcano is in or what kind of eruption is taking place. To learn how to do that is the purpose of the sequences of volcanic eruptions worldwide brought together for you now in this video. Some will be new to you. Others you'll recognize. But if you miss a name or an event, there is a checklist in the study file using the video page numbers on screen. Now your task is to describe exactly what you see. To help you, we'll gradually introduce some of the specialized terms which Earth scientists use. These eruptions are on Hawaii. How would you describe what is happening here? Let's run that sequence again. To describe it, a good place to start is at the vent, the source of the activity. Here, molten rock or magma is coming to the surface and being sprayed high into the air. We call this a fire fountain. The globules of magma, or spatter to give them their precise term, are landing around the vent, building up a small cone. It appears that the hottest spatter coalesce into a continuous stream, which we see flowing through a breach in the cone, producing a river of magma which we refer to as lava. Lava flows downhill, reaching speeds of several meters per second. With time, a dark skin grows over its surface due to cooling and solidification, and this slows the lava down. Towards the edge of the flow, its thickness has decreased to only a meter or so, no higher than a person. But what's happening here? Obviously, it's cooling down. Only some parts of the edge of the flow are glowing red. In these areas, magma from the hot interior of the lava flow breaks through cracks in the crusted over surface and oozes out. It's a much tamer environment than the active vent. At night and from the air, the fire fountains and lavas make a spectacular sight. Sometimes called curtains of fire, these reach hundreds of meters into the air. But what do you think an Earth scientist would find significant about the eruption you are seeing here? Well, clearly it extends along in a line, for many kilometres in fact, and this gives us a clue as to what must be happening underground. The lava is escaping through an area of weakness, the magma being supplied through a system of broadly parallel cracks and fissures which extend a considerable distance. That's why the curtains of fire are arranged in rows. How do these eruptions compare with the ones we've just been looking at? Both have spectacular fire fountains up to several hundred meters high and streams of lava. The differences are really just of scale. This lava flow is on the Italian volcano Etna on Sicily. How would you describe it in comparison with the lavas we saw from Hawaii? Not all lavas are the same, and the Etna lavas are generally thicker, more sluggish, and are covered with lots of jagged boulders. The rough surface of this ancient lava on Etna is very different from the smooth surface produced by many Hawaiian lava flows. It's important to get the observations right before you even start considering explanations. Explosive, an obvious description of this event. The materials being erupted are a mixture of large and small fragments of rock and magma, together with hot gas. Where do they end up? Blocks of rock are thrown out of exploding magma in the vent. These fragments range in size from blocks larger than a metre across down to dust-sized particles, and they are called pyroclasts. So, this is an example of a pyroclastic eruption. Although the largest pyroclasts quickly fall back to the ground, accumulating near the vent, the smaller ones are carried higher into the atmosphere in billowing clouds. This produces an eruption column containing pyroclasts, hot volcanic gas and air. The whole mixture floats upwards because it is less dense than the surrounding atmosphere. In this much larger example from Indonesia, the eruption column rises through white weather clouds and reaches a height of about 10 kilometres. Eventually, an oppressive dark cloud of ash is produced, and the pyroclasts fall back to Earth. Other examples again show how the eruption column towers into the atmosphere, where it spreads out and is blown downwind. What hazards can these eruptions pose to people around the volcano?
A mushroom cloud of ash and gas hung 15 miles high as Mount Pinatubo erupted with still more fury. Lumps of pumice the size of ping-pong balls fell up to 25 miles away, forcing more Filipino villagers to flee the area. They used any form of transport, as their land and homes were threatened by molten rock and boiling mud. There have been burns and other injuries, but because scientists gave early warning, the eruptions have so far claimed only 2 lives. More activity is predicted from the volcano yet. Slicks of ash have caused road accidents, and after airliners sucked ash into their engines, flights have been diverted. Those who've left their homes around Mount Pinatubo, 40,000 in all, have crowded into evacuation centres at schools. After 6 peaceful centuries, they say, the 5,000-foot volcano has awoken from its sleep.
This sequence and the next one show 2 pyroclastic eruptions of Mount St. Helens. But how do they compare? The first one showed a rising eruption column. Whereas the second sequence showed something new, a rapidly flowing mixture of gas and pyroclast sweeping down the volcano. We call this a pyroclastic flow. At Unzen volcano in Japan, the summit crater is plugged by a rugged mass of hot but almost solid lava. What happens next? When the edge of the lava collapses, apparently under its own weight, hot rocks and gas tumble downslope, gathering speed and mixing in air. This soon turns into a pyroclastic flow which moves at up to 100 meters per second down a steep valley on the side of the volcano, destroying everything in its path. Augustine in Alaska is another volcano which has produced pyroclastic flows. How do you think the materials in flows of this kind must differ from the materials in a rising eruption column? These flows are a mixture of pyroclasts, volcanic gas and air. But because they flow downhill and across the ground, they must be denser than the surrounding air. Let's draw together some general ideas about volcanic eruptive styles. It is possible to classify the eruptions into three types. First, those which produce lava flows. Lava flows can form when magma wells up out of a crater directly onto the ground and from the spatter produced in fire fountains. They can move over broad areas, flow in well-confined channels, or just pile up within the vent. Lava flows move sufficiently slowly that they are easy to escape from, but property in their path is vulnerable. In the second type, explosive eruptions launch large blocks of rock into the air. And in some, a tall eruption column of smaller pyroclasts and gas rises into the atmosphere. The column can reach tens of kilometers, presenting a hazard to aircraft traffic. The pyroclasts eventually fall out of the eruption column and blanket the land around the volcano with a layer of volcanic ash, causing damage to property, crops, and disruption to life. These are the third type. Pyroclastic flows, fast-moving currents of hot gas and pyroclasts which sweep down the sides of volcanoes. Pyroclastic flows travel much faster than lava flows and are nearly impossible to escape from. They are an extremely dangerous volcanic hazard. They form from a mixture of gas and pyroclast which is denser than air and can spill out from the vent of an erupting volcano, or develop when hot lava collapses and disintegrates. Finally, we recommend that you complete the activity associated with this video before returning to the block text. There, you'll discover a connection between the type of eruption and the location of a volcano.
Now that we are some way into the course, we've included another activity looking at study skills. You'll see a group of students discussing how they managed to keep up with their work and how they've coped with a number of difficulties that have come up along the way.
It's inevitable with so many commitments that we have that we fall behind. How do you all manage when you've fallen a couple of weeks behind with the work?
I think everybody has dropped behind somewhere in the group. I mean, it can be just that you're studying slow or you're getting stuck on a thing, and even though you know you shouldn't get bogged down, when everybody else has got the unit and you can't understand it, you tend to linger on it. And you have to speed your actual studying process up by only kind of spending time on the parts that are relevant or important, or the bits that you're finding a little bit more difficult.
Have a preview look at what's coming up in the TMA, and
that helps.
You know, pick out the parts from the units that are actually relevant to the TMA, and you don't like doing it, but you do end up having to leave some bits out.
The summaries are very useful at the end of each chapter. They highlight the important points, so if you are struggling, I mean, if you're really behind, it's very easy to drop behind, you read the summaries and sometimes refer back to the bits that they've summarised it.
Is that the way you managed, Chris, when you were hospitalised and you were unable to study? How did you catch up after?
I mean, the first thing I did is I got in touch with my tutor and I let him know what was going on. And he said that there were lots of ways in dealing with it. And I said that I thought that I could catch up. But I got an extension time for my TMA because it was quite a big one. There was a lot to do.
You've got different problems though, Safina, haven't you, in trying to find time to study?
Yeah, because of the kids. I mean, there's a couple of us in our tutor group, and what we do is we've got a self-help group running. So what we do, we meet here on Mondays, so we try and definitely get together towards the end of the week so we can get some work done there, because we've all got kids, and some are at work and some aren't, and some haven't got kids. So really the motivation, we just really have to push ourselves to make sure that we get together so we can get the work done.
We had a tutorial on physics, and the phrase, obviously, this is, and everybody sat there with blank faces, and I know, I went home and I kicked my books around the living room and that's it. I'm not doing it anymore, I'm jacking it in, I can't cope with this. I'm obviously stupid. And then we had a study group 2 days later and everybody came in with tatty books because they'd all kicked the books around. And
when we actually got together, we found out everyone was at the same stage, thinking, oh God, I'm the only stupid one. You know, everybody else can understand these.
And you had a difficult time as well, Ruth.
Yes, my father was killed just before the start of an OU academic year, and at the time I thought, am I going to be able to cope with this? I was very, very upset. It feels as though the world's caved in on you. But I thought you can either sink or you can swim in this kind of situation. And you either give up or you carry on. And I carried on and I succeeded. But it was not easy at times, and I went through a very bad period where death was very foremost in my life, and I was very panicky about it, and had to see the doctor quite a lot and had counselling as well for a while. But I came through it with a lot of support from friends and family, and also from tutors, because they are there to help. They're very approachable, and if you just ring them and explain your situation, then they will do their best to accommodate you with any problems that you've got.
You tend to start off thinking as the tutors, as teachers.
Yeah, it's very
and
different.
that barrier's there, but they, like you say, you ring them up. I mean, I know some of our tutors have been rang up at the midnight hour with questions, and they're good about it.
Yeah.
And they helped a lot with my kind of break. So, and now I'm back up. Well, I'm back as far behind as everybody else is.